In this video, we're going to talk about displaying quantitative data with histograms. So what does a histogram look like and what does it show? So this is a histogram. Looks kind of similar to a dot plot, but has a y-axis, and it shows each interval of values as a bar. So please note that the x and y-axis, at least in this example, has numbers. How might you make a histogram, you ask? Well, let's talk about these steps. So the first thing to do is to choose equal width intervals to span the data. 5 intervals is a good minimum. You make a table that shows the frequency or count or relative frequency, which is the percent or proportion, of individuals in each interval. So you figure out what values fall in those intervals and you make the bar however high you need to make it. So you're going to draw and label the axes. That's pretty standard. You draw horizontal and vertical axes. You put the name of the quantitative variable under the horizontal or x-axis. And to the left of the vertical axis, you indicate whether the graph shows the frequency, which is the count, or the relative frequency, which is a percent or proportion of individuals on each interval. You're going to want to next scale the axes, so place equally spaced tick marks at the smallest value in each interval along the horizontal axis. And then on the vertical axis, you start at 0. You know this, we always start at 0. And you place equally spaced tick marks until you get the largest frequency at the top. And then you draw bars. You make the bars equal in width and leave no gaps between them. So that's the deal with a histogram and how it visually, one way at least, it visually differs, there you go, from a bar graph. Histogram, the bars touch each other. They're friends. And as you can imagine, an interval with no data values will appear as a bar height of 0, so no bars for no values. Now let's talk about an example and work through making a histogram together. So this example is called How Much Tax? One of my absolute favorite topics. Just kidding, not at all. So the problem is about sales tax. So the sales tax rates vary widely across the United States. 4 states charge no state or local sales tax. That's Delaware, Montana, New Hampshire, and Oregon. So this table down below, which shows the rest of those states that do charge sales tax or local sales tax. And of course, we can't forget about DC, the District of Columbia. So here's all those 47 states information. And so let's make a frequency histogram to display the data. And then let's answer the question, what percent of values in the distribution are less than 6.0%? Interpret this result in context. All right, so what we're actually going to want to do is take this data, this chart, and turn it into another chart. Apologies for how it's laid out here. There's a lot of data here. This is the best way I found to do it. So we want to put this into a frequency chart because it's asking us to make a frequency histogram. So essentially what we're going to do is we're going to count up all of the states that have each interval of sales tax. For example, we're going to do it in whole number intervals. So 1 to less than 2. So that's 1.0 to 1.99999 if that exists. And then 2 to 2.99999, etc. So we're just going to count up the number of states that fall into each of these intervals. So what I've done is I've tried to color code this to the best of my ability here. There's only one state that falls between 1 to 2%. There are no states that fall between 2 to 4. There's one state that is in the 4s, 6 are in the 5%, 15 are in the 6%, 11 are in the 7s, 9 states are in the 8%, and then 4 states are in the 9%. Woo! So now that we have our frequency table, we can make a frequency histogram. So we've chose equal width intervals. That's our 1 to less than 2, 2 to less than 3, etc. We made a table. Now we're on to these 3 last steps here. We're going to draw and label the axes. So I've drawn our axes and I've labeled the variables. So the number of states and then the tax rates is here down in the bottom. And so now I want to put my numbers or scale my axes. So I'm going to put the tax rates down here. So all of these intervals and then the frequencies will go from 0 all the way up to 15 on this axis. So the x-axis I labeled from 1 to 10, and the bars are going to take up the distance from each of these notches. So from 1 to 2, there'll be a bar. From 2 to 3, well, there won't be one technically, but you get the idea. And then I scaled my y-axis here in terms of 2s. Apologies, you know my handwriting on my iPad. Yeah. So let's make the bars now. All right, so you don't have to color code them to your table, but I love it. So here are our bars, and make sure that they're roughly the same width. Sometimes that's hard when you're doing it on a non-grid background, but this will do. So from 1 to 2%, right, we've got one state. And then for another example, from 6 to 7%, we've got 15 states. So here's our lovely histogram. Now with our visual display of our data, we can answer this question of what percent of values in the distribution are less than 6? Interpret this result in context. So what I'm going to do is count up the number of states here that are 6, well, below 6, because we know that that really stops at 5.99999, etc. So that is 1 plus 1 plus 6, or 8 out of 47 states. So that's 17% of states, including the District of Columbia, that have rates less than 6%. Let's now jump to making a histogram on your calculator. So these screen grabs and these directions will work best with a TI-84 or a TI-83. You don't have to have the colored version of the TI-84, but it makes it nice. So first thing you're going to do is you're going to hit Stat, your Stat button, and you're going to choose Edit, and you're going to put in your values on your list, just like you would with a regression, for example. Now you're going to want to make sure that your stat plot is on because we are dealing with statistics. We hit that stat button. So you're going to go to second y equals up at the top of your calculator, and you're going to hit enter and go to number 1. You're going to turn that plot on, and we're going to make it look like a histogram, which in this example or on this calculator is the third graph in. So you're going to want to go to Zoom and then Zoom Stat so that it will display an actual histogram for you. And then you can trace to examine the intervals there. So these don't come labeled, but by tracing it, you can figure out, okay, is that 1? Is that 0.1? Is that 0.5? What are the intervals? Because that's important. So you can actually adjust the intervals that your calculator counts by, whether or not it's stats or just a regular graph. You can tell it how to display your data. And so you'd hit window and then it will tell you what it's counting by. So that example from the previous slide was going from 0 to 11. It was counting by 1, and then the y minimum was at -5 and the y maximum was at 20. Obviously these are going to change depending on the data that you enter in that first step where you go to edit your lists. And so that actually, if you were entering in the data that we were just working with about sales tax, this would be your histogram, for example, because the width is counting by 1, that's X scale. And if you wanted to change that, so this was counting by 1s, if you wanted to count by 0.5, you would change that X scale to be 0.5 or whatever you want it to be. So let's now talk about some really important things about histograms now that you know how to make them. First thing being, the choice of intervals in a histogram can affect the appearance of your distribution. So this graph represents the nicer looking histogram that we just made together about the tax rates of 47 states, including DC. Now, the width of our bars, or the width of the intervals, was about 1%, right? We went from 1 to about 1.999 to about 2.999, etc. Now, that's the display that you get when you have a width of 1% or an interval of 1%. But what if you chopped those intervals in half and you did 0 to 0.5% and 0.5 to 1% and 1 to 1.5%, etc. You get a different looking distribution because your data values would fall into different intervals. So you might want to think ahead a little bit as to how you want to display your data and how your intervals will impact what you're looking for. So here's where we're going to get to the difference between histograms and bar graphs. They are different. They look visually very similar. One thing that we already discussed is that histograms, the bars touch, and in bar graphs, they do not. And don't take the coloring of these two as that bar graphs are colorful and histograms are not. You can apply color to both of those or not, up to you. So the thing about histograms versus bar graphs is that bar graphs over here display distribution of categorical variables. So for example, that graph that we looked at in our bar graph video had to do with preferred communication method of cell phone, Facebook, in-person, text messaging, etc. So note, those aren't numbers. Those aren't intervals. Those aren't quantitative. They are categorical. Bar graphs, categorical. Histograms, quantitative. Look at those numbers on your x-axis. All right. That's a big difference. So for a histogram, the x-axis identifies intervals of values, so intervals of values, where the x-axis on a bar graph displays categories. Something else you want to keep in mind when you want to compare multiple things using a histogram, make sure instead of using counts, so for example, number of states with a certain tax interval, that you want to use percents or proportions instead. Let's take a look at an example. So both of these histograms represent data where we're comparing word lengths in articles from a biology journal compared to an airline magazine, because those things are related. In graph A, what we're using on the vertical axis here is the frequency at which you see these different word lengths in the journal and the magazine. Now, a frequency is essentially a count. Not the best way to display your data using a histogram. Instead, over here, highly suggested to use the percent of the word length that you see in both of these things. So we want to use relative frequencies instead of counts or regular frequencies. And last little bit of advice that applies to histograms and any other graph or display of data you might see, and that is just because a graph looks nice doesn't make it a meaningful display of data. So these two graphs represent essentially the same data. So there was a class of 15 students that counted the number of letters in all the names of those students in that class. And so this one on the left, a student just went on to Excel and said, all right, make me a graph, and this is what Excel did. And notice that we've got a bar graph, not a histogram. The bars aren't touching. So you've got all 15 students and then their first name length. Now, that's not bad necessarily, but it really doesn't tell me a whole lot about what relationship the students in the room and the lengths of their names have. So let's fix it by using a histogram, and then on our x-axis here we have first name length, so from 0 to 3, 3 to 4, 4 to 5, etc. So that is the number of letters in their first name, and then the frequency, so how many students have that name length or those number of letters in their name. This one we can deduce a lot more information from, while this one, again, like I said, not bad, just not the most useful. Whew, wowee. That's the end of this video. Thank you for watching.